Lesson 10.3, Trigonometric Functions of Any Angle. All right, think of a point on the terminal side of an angle. Wait, maybe this point right there, which we'll call xy. You can draw a right triangle with the x-axis. So we have this nice little right triangle that's formed. The hypotenuse is r. So sine, which is opposite over hypotenuse. Now we're going to use this angle here in the center. And so the opposite is y and the adjacent is x because it's over x and up y to get to the point xy. Hypotenuse is r. So sine is y over r. Opposite over hypotenuse. And cosecant is its reciprocal, r over y, or hypotenuse over opposite. Cosine is the adjacent over the hypotenuse. In this case, it's x over r. And secant is its reciprocal, r over x. And tangent is y over x, or opposite over adjacent. Cotangent is x over y. So why do we care? Well, that's a different angle, isn't it? Well, yes, that little acute angle is different from this big obtuse angle. But because of the symmetry, it turns out that it's the same. Ooh, exciting symmetry. If it's a unit circle, the radius is 1 unit and things simplify. Sine would just be y. Cosine would just be x on the unit circle. So evaluate the 6 trigonometric functions for theta. So our point here is x and y, and we need to find r. R is always going to be the square root of x squared plus y squared. Why? Because if I draw this right triangle, that's x and that's y and that's r. So x squared plus y squared equals r squared by the Pythagorean theorem. So 3 squared plus negative 3 squared equals 9 and 9 makes 18. If we simplify that, that is 9 times 2. The square root of 9 is 3. Square root of 2. So r is 3 square root of 2. So sine is y over r, or negative 3 over 3 square root of 2. Oh, I can't have a square root in the denominator. And the 3's will cancel out. So it looks like it's negative square root of 2 over 2. Square root of 2 times 2 is square root of 2 times square root of 2 is 2. Cosine of theta is x over r. X is 3. R is 3 square root of 2. 3's cancel. Rationalize because you can't have a square root in the denominator. You get square root of 2 over 2. Tangent is y over x. Y is negative 3. X is 3. Oh, 3's cancel, so it's negative 1. Cosecant is r over y. R is 3 square root of 2. Y is negative 3. Those cancel. You have negative square root of 2. Secant is r over x. So that's 3 square root of 2 over 3. 3's cancel, you have square root of 2. And lastly, cotangent is x over y. X is 3, y is negative 3. 3 is canceling of negative 1. Why don't you try number 3? The answers are in the back of the book. We have what are known as quadrantal angles. Those are angles that the terminal side is right between two quadrants, so it's like a pi over 2 or pi or 3 pi over 2. But they're done the same way. So let's evaluate the 6 trigonometric functions of 180 degrees. Well, if I graph that, it starts here on this side, and 180 degrees is over here on that side. But I need a point on the terminal side. So what's a point over here? Any point will do. Simplest one would be negative 1, 0. And then that distance is r, so how far is it from 0 to negative 1? The distance is 1. R is always positive. Remember, it could be found that way also. So sine is y over r. Y is 0. R is 1, so that's 0. Cosine is x over r. X is negative 1, r is 1, so you get negative 1. Tangent is y over x. Y is 0, x is negative 1. Cosecant is r over y, so that's 1 over 0. How do I divide by 0? That's right, it is undefined. You can't divide by 0. Secant is r over x. R is 1, x is negative 1, so secant is also negative 1. And cotangent is x over y, so that's negative 1 over 0. Again, we're dividing by 0, so it is also undefined. Exciting, huh? To help us identify or evaluate trig functions of any angle, we can use a reference angle, which is an angle between the terminal side and the x-axis. So this angle here, that's the reference angle. It always goes to the nearest x-axis. And the reference angle has the same values for the trig functions as first quadrant angles. So for example, if this angle is, say, 30 degrees, it's going to have the same values as the 30-degree angle over here. The only difference is negative signs. What's written here is what's positive. All means sine, cosine, and tangent are all positive. Sine means sine's positive, but cosine and tangent are negative in quadrant 2. In quadrant 3, sine's negative, cosine's negative, but tangent is positive. And in quadrant 4, sine's negative, cosine's positive, and tangent's negative. It's way to remember it is all students take classes. And of course, the reciprocals are with their functions. So secant would be with cosine. So let's sketch our angle and then find the reference angle. So 150 degrees. So this is 0, 90, 180, 270, and 360. So 150 is between 90 and 180, and it's closer to 180. So Probably something like that. The reference angle goes between that and the nearest x-axis, so that is the reference angle. To find its size, it's just the difference of our two marks. So it'd be 180 minus 150, just 30 degrees. So our reference angle is 30 degrees. Why don't you try number 15, which is 23 pi over 4. Give you a hint. You're going to have to find a coterminal angle until you get an angle that's between 0 and 2 pi. So pause it and do that. Your reference or your coterminal angle is the same as 7 pi over 4. And the reference angle is pi over 4. All right, so now we can use reference angles to evaluate functions without a calculator. So evaluate cosine of negative 60. Well, some of you will do just fine with the negative 60. Some of you will need other help. So what I will do is I will find a coterminal angle between 0 and 360. So I will take this and I will add 360 and end up with 300 degrees. So 300 would be about there. Or if you like, also negative 60 is there also. The reference angle is here between the angle terminal side and the x-axis. So to find that reference angle would be 360 minus the 300, which is 60 degrees. So our reference angle is 60 degrees. Now what we're going to do is we're going to find cosine of 60 degrees. Well, we could use a special right triangle of 30, 60, 90. The sides go 1, 2, square root of 3. There's the 60. Cosine is adjacent over hypotenuse, so that's 1 over 2. And now you just have to figure out the sine. So this is all students take classes. So cosine is positive in quadrant 4 where this angle is. So it is 1/2, positive 1/2. If we were in quadrant 2 or 3 with the reference angle of 60, it'd be negative 1/2. Why don't you pause this and try number 25, sine of negative 150. And your answer should be negative 1/2. Our problem-solving problem for this lesson is estimating a horizontal distance of a projectile, in this case a red kangaroo, who jumps at an angle of 8 degrees with an initial speed of 53 feet per second. All right, so you need a formula. When you're in feet per second, your distance is the initial speed squared over 32 times sine of 2 theta, where theta is the angle. So that's theta, and the 53 is the v. So our distance is 53 squared, and that has to be in feet per second, over 32. Oops. Sine of 2 times 8 degrees. Let's use my calculator. 53 squared divided by 32 times sine of 2 times 8 gives us 24.2 feet.